astronomers of the Space Telescope Science Institute, and it is my immense pleasure to interview for SETIcon Chris Ford, who his business card lists him as the business director for Renderman at Pixar Corporation, and he has an incredible background and a wide variety of things that he likes to do. And we don't have our fire for our fireside chat, but
it's cold.
We'll have to make do on this chilly 70-degree morning. So the audience probably knows a lot about Pixar films. Everybody knows about the Pixar films. But Pixar has an entire software side to it. Mm-hmm. So why don't you describe what you do as business director and the whole software side of Pixar?
Yes, morning everyone. As I said, when you think of Pixar, you think of us as a feature film studio, and of course we are. But you may not know that Pixar actually provides the photorealistic rendering image technology for the whole visual effects industry. This really started way back in 1986 when Steve Jobs first bought Pixar from George Lucas and decided to try to make it into a software and a hardware company. And that was what Pixar was for the first 6 to 8 years of its existence. In 1993, the company did a left turn and became a film studio with the release of Toy Story. But that core tradition of technology and software development to produce photorealistic imagery, applicable in many ways, not only to feature films, but to visualization, including astronomical visualization, has always been core to what Pixar is. And that essentially is the part of Pixar that I actually manage at this point.
Right. So would it be fair to say that most every Hollywood blockbuster that they've seen, some of that has been rendered with using the Renderman software?
Pretty much every blockbuster you've seen. For example, like 19 out of the last 20 Academy Awards in visual effects all used visual effects that were rendered in our software. So if you think of milestones going all the way back to Jurassic Park, but you come forward to Titanic or Star Trek or Lord of the Rings, Avatar, Prometheus, which is out at the moment, all of those have used our software technology. And that's an aspect of Pixar probably most people are not aware of.
Right. And so how much of your development of the Renderman software is driven by internal demands and saying, oh, look, we got the new Brave is coming out, right? And so we need flowing hair to be better, or we need this water effect.
Yeah.
And how much is, of course, driven by your external customers who are saying, well, we're doing Prometheus and the atmosphere effect has to be much better, and so what can you do to help us there?
So the answer is both. The question is often asked, why does Pixar do this? What's in it for Pixar? You're a successful feature film studio. Why do you provide this technology to everyone else? Aren't these people your competitors? But the actual reality is they're not. It actually helps us to have our technology tortured and stressed by the entire entertainment industry to push it in ways that we might not do this time around, but we may need to do in the future. So the reality is that rendering is an extremely sophisticated discipline. The complexity of the task to produce photorealistic imagery really demands a level of testing and exposure that no one studio can really put into the process alone. So it really benefits us. So we learn from our users just as much as they learn from the types of effects which go into our films.
All right, great. Now, I also noted in your resume that you've been at a veritable who's who of computer graphics. I think it was Silicon Graphics, Alias, Autodesk. Can you just give us a very quick rundown of your career?
Yeah, actually I started out as originally in production. I kind of have backgrounds in both computer science and in design. Kind of like many people in this industry, we're kind of left brain, right brain thinkers, have managed to kind of fuse the two together. And I realized that at one point in my career, this was in the early 1990s, I became more interested in the means rather than the end. Most people who are certainly creative are in the business to use tools to produce a creative result. I actually became more interested in cheating, which is really what we do, right? You're cheating a visual effect to fool you. And remember, every time you watch a movie, you are being manipulated in some way by the way that the visual effect is assembled or the animation is assembled. So I became really interested in cheating. So that's what I am, a cheat. So I got into the tools side of the software business, And I've lived with the evolution of that ever since. So the companies that are associated with that are companies with names like Silicon Graphics. Many of you may have heard of them. They were a pioneer in computer graphics hardware. Wavefront and Alias produced early software animation tools. Later they merged. They produced a software application called Maya. I was one of the design engineers and the senior product manager for Maya in its first versions. And really developing the features necessary to produce the types of amazing effects you see today. I moved to Autodesk, which is another major vendor of 3D software design tools, and then to Pixar, where I currently am. So I've essentially been collecting the set as far as 3D visualization, rendering, and software applications is concerned.
Well, in as much as we used Maya in creating our 3D sequences at Hubble, we thank you for your participation in the development of such wonderful tools.
I can't say it was easy. It was hard work.
It's not hard work, it's not fun.
Yeah, these are big, complicated applications because really you're trying to simulate reality inside a computer.
All right, so let's move to the stuff that you don't get paid for.
Right, yeah.
All right, it says that you are president of the Mount Diablo Astronomical Society.
Right.
So you've obviously been interested in astronomy. How did you first get started? Where did your interest in astronomy develop?
I think it was when I tried to make a telescope out of my father's shaving mirror. So I've been an amateur astronomer for actually my entire life, and both as an observational astronomer and also one just interested in the latest developments and discoveries and so on. But I've always kind of been interested in tying together my interest in astronomy with what I do in my day job. I'm also an astrophotographer. I like to image astronomical objects, and I get a little bit frustrated that everything is flat. We all know that the world and the universe is very three-dimensional. I'm a very three-dimensional person. I hope you regard me as such. And I'm very interested in kind of interpreting what we see astronomically through the tools that currently exist and will exist in the near future.
So, do you own a telescope? And
I actually own 6 telescopes.
All right, and how often do you get out to observe? Because I know that my schedule gets so busy that my hobbies have taken a back seat, especially with my kids for the past decade.
So I have 6 telescopes at the moment, yeah. I've actually automated the process for imaging in many ways, so I can actually automatically observe from my backyard, controlled by a computer, while I'm kind of stirring the pasta sauce, or something like that. No, I don't get out as often as I need to, especially as to produce really high-quality astronomical images. You need to be in very dark locations. If you're living in the Bay Area, as I do here, the light pollution means that generally you're restricted to what's known as a narrow-band imagery, which essentially cuts out the light pollution in the area. But yeah, no, I'm always kind of engaged in astronomical imagery and how I can interpret what I'm doing in meaningful ways.
So let's explore that 3D aspect of it that you mentioned, because it's sort of a natural combination to take your CG history and take your astronomy interest. And then I've noticed on the web that you produce several very interesting three-dimensional interpretations of the astronomical imagery. You want to talk about how you've done that?
Yeah, in fact, let me even just refer to the fact that there's almost a secret history between the development of computer graphics software techniques and astronomy. And you're probably thinking, there is? So, some of you may recall Voyager and the original animations that were assembled for Voyager. And they were the first use ever in a public context of shaded, textured objects in 3D. You look at various Star Trek movies, you look at various shows in Planetary and IMAX. All of them pioneered certain techniques, certainly with particle systems, for example. Point is that I was particularly inspired by the fact that those techniques that were very cutting edge at the time and really the domain of a professional are really accessible to everyone now. And so, these tools I have been applying to produce three-dimensional visualizations in my own home and from images that I take. And it's a pretty straightforward process. You take the image, you layer it in various ways, you construct an artificial parallax so you can have a slight perception of depth. You can make them stereoscopic. And I'm talking about something that should really be shown. And I can actually even show you some examples after this talk if anyone's interested. I have them on my laptop. But I find that it's just a great way of conveying the wonderful three-dimensionality of the universe to an audience that normally thinks of the universe as a flat image, and it's not that.
Right, and that's exactly what we do
Right.
at Hubble for a lot of our press releases. We're putting things into 3D just to remind the public that
Right.
they aren't these pretty picture postcards. Now, you've given, let's see, all right, you got through that all in, I had 3 questions there, you got through them all in one answer. You moved past me very quickly. All right, so switching, I missed my, there we go. That's where I wanted to. Okay, so you've done astronomy. And do you want to take these 3D astronomical presentations any further? You say you've done them in your home. I've seen you post them on the web. Where would you like to go with those? You want to get those involved in any of the professional work?
Yeah, I mean, I think of them primarily as a tool for outreach, for communicating to individuals. What they're looking at is actually a complex and interesting and three-dimensional form. I think from a professional perspective, the tools to produce very realistic, high-fidelity, high-definition astronomical visualizations are actually evolving very rapidly at the moment, and that there is potentially a significant revolution, that's a often overused word, in the way that we can produce three-dimensional scenes heading our way within the next 3 to 5 years in a way that will impact the way the public can engage visually with astronomical objects.
And on that point, you are a member of the board of directors
Right.
of the Astronomical Society of the Pacific.
Right.
And so when did you join them, and what is your plan to revolutionize because their mission statement includes advancing astronomy and science literacy through presentations to the public. And so how can we take it to the next level in Astro EPO and your work at ASP?
So I'm very conscious of the fact that there is a generation of the astronomically interested public that was essentially driven and inspired by the early space age, right? The Apollo missions and all of that. And that driver no longer exists, unfortunately. I think I'm a little frustrated. I would rather be living on the moon by now. Somehow, what happened?
You'd have better skies there.
I definitely would have better skies. However, we have the YouTube generation. The modes of communication have changed. People's attention to detail, attention span is different. I use that term, the YouTube kind of generation, deliberately, Generation X, call it what you like. But I would like to recreate a new generation of visual tools for that generation that are really adapted to the way that they assimilate and take in information. So this really relates to my interest in being a board member at the ASP, is kind of taking astronomy outreach into the 21st century. So kind of what does that mean? What are these tools that are going to develop that, I refer to? First of all, let's just talk about some of them. Personal electronics. Everyone has a cell phone, right, these days. We've all seen applications on cell phones that are useful in an astronomical context. Some of the, we've seen planetarium applications. There's, some of you know that well-known exoplanet app that kind of sends, pings your cell phone whenever a new exoplanet is discovered. I just mention these as examples of how your personal electronics can be integrated into a larger information sphere, which is sending information your way.
Having an internet-connected device with you at all times
absolutely
changes the way you think about how you interact and get your news from the world.
Right.
But also the capabilities available to you, the cloud computing, the cloud data sets that you can have access to.
Right, and in fact, I can touch on the cloud in a minute. So I've been doing some experiments, for example, with my iPhone. Last year I went to a dark site in Oregon, and I just put a very fast lens, optic lens, with a little custom app on the iPhone and took deep space images with my iPhone. And it works. And I kind of like the idea that, if something astronomically interesting happens, you get a little message, text message on your iPhone saying, point it here, and you can kind of move it around until you're pointing in the right direction, and then says, take picture, and then it's yours. It's kind of a personal engagement with something that's happening in real time. The cloud is particularly important because, of course, it brings significant amounts of computational capacity to your doorstep or to your cell phone without you actually having to have that capacity on the device itself. That then ties into developments in computer graphics, which I think are very interesting over the next few years, particularly in the case of physically accurate lighting and shading and 3D environments that essentially follow the laws of physics, but until date, to this point, have really been too difficult to do just because they take too much processing power. But processing power, Moore's law, all of that continues to increase. There are amazing developments occurring at the moment in photography, especially in an area known as computational photography, which essentially involves the simulation in the computer of the entire optical train of a camera or a telescopic system, enabling you to manipulate images in ways that were impossible just a few years ago. Some of you may have heard of this LITRO camera, which takes what's known as a light field and enables you to do very bizarre things like change focus after you've taken the image.
Right.
All of these, are individual little separate items that, when you connect the dots, I think can really change the way that we engage.
Right. So for the audience, you can now have a computer inside your phone that
Right.
allows you to do other things. You take that computational power, you put it inside the camera, produce the information that you can then use in the computer to do a whole sort of host of post-processing that frees you up when you're
Right.
doing your actual filming.
Right. Yeah, a lot of this is connecting the dots, I think. And those dots are there to be connected at the moment, and they are being connected.
So I have to ask you the most difficult question in astronomy education and public outreach. Where do we get the funding? Because there's a ton of really cool projects that are available out there. And I've always found the most difficult question is, how do we get people to pay for
and
it?
I think what's interesting, so I spoke about connecting the dots. What I think is really interesting about all of these developments is that it's not driven by some obscure research or academic program. This is driven by the consumer marketplace. Just take the case of computational photography. The consumer marketplace, with its economies of scale, will drive that and its adoption very quickly. The cloud is a similar example. So I think in the actual development of the technology, that's falling into place already.
Right, I agree.
And really, the job of connecting together, that's far easier, that's far less expensive. The key, ultimately, is to put something in front of the public that's engaging and interesting, and astronomy is so visual and so, compelling a subject. I mean, if any science, is easy to market, astronomy must be it.
It does have a wide appeal, and we rely on that at Hubble.
Right.
And it could be the killer app as
Right.
we go into the future. All right, let's take another left turn and talk about aliens, because this is a SETI conference,
Yeah.
right? So we got to talk about aliens.
Yeah, and I must admit, when Seth Shostak invited me to SETIcon, I kind of thought he had me down as the fake aliens guy.
All right, so let's talk about fake aliens, okay? Because one would think that creating a fake alien, a complete, creation from your imagination, you have to build the whole thing from scratch, would be really difficult. But yet, you tell me it's harder to actually create a human for which you've got, tons and tons, unlimited reference material.
Right.
So can we talk about the uncanny valley that comes up in computer
Yeah,
graphics?
I mean, we've all seen aliens in movies, right? And they look pretty good, right? Non-human characters, going back to Gollum in The Lord of the Rings, so you can go back to dinosaurs, if you like, in Jurassic Park. All of these, pioneered the state of the art in essentially generating synthetic characters in the computer that you could put on a large screen and convince you sufficiently enough to hold your attention for the duration of a film. However, when you get into really human-type figures and figures that are almost or meant to be totally realistic, that is actually really hard. And it's not a case of producing a rendered image of a synthetic human that is hard. That's done now. You can go to the web and you can look at computer-generated pictures of people, and they look pretty real. As soon as they move or they're animated, everything falls apart.
There's a whole industry of digital models
Right.
available.
Absolutely.
That you can download and pay for the use of this digital model
Right.
To wear your clothes in your advertisements.
Right. So the uncanny valley, which you referred to, is actually a fairly well-known theory in robotics and psychology.
Strongly demonstrated in Final Fantasy.
And and there are movies that are often brought up, like Final Fantasy and Polar Express is another one, which absolutely not to diminish the enormous technical achievement of those movies. You know, they were pushing the state of the art in producing characters that you could believe in. But you know, you look at the eyes, you know, you realize that this is a really difficult problem to solve. The uncanny valley essentially is, if you were to graph your reaction to these characters, you know, the more human they get, the more you accept them. And then you get to a stage and all of a sudden, your acceptance turns to revulsion. And you're down in the valley. And the only way to get up into the other side of that valley is to actually make them hyperreal. So you can no longer tell that they are, you know, non-human characters. Now, actually, that has been achieved recently, maybe to some extent within the movie Benjamin Button, where Brad Pitt, essentially in the first 90 minutes or so, was rendered as an, you know, a far older version of himself, and it was a synthetic character.
But of course, that relies on motion capture.
It relies on, but even motion capture doesn't entirely solve the problem, because motion capture, which essentially involves putting sensors on your body and using that to drive a character, is a sampled, digital, if you like, process. Human beings are analog. You know, if you study the whole process of how we relate to each other, you know, we're very well trained to look at each other from childhood onwards, and often it's what isn't there, which is as much a giveaway as what is. Right. So this is still a difficult problem. It's why you don't see digitally recreated Marilyn Monroes or John Wayne, you know, in the movies today, even though I'm sure their lawyers would like lots of money, or their estates would like lots of money as well. And another reality, it's pretty expensive and difficult to do, and there are plenty of unemployed actors waiting tables in LA who are a lot cheaper.
All right, so even if the CG can't fully get humans, you still think it can play a role in SETI, especially in terms of the idea of first contact being virtual. You want to explain that idea?
Yeah, I mean, this is not a new idea, but I mean, the more I think about the way, you know, history almost unfolds, technology unfolds, it often doesn't unfold in the way we think it does. You know, I think much of our thinking of how will we make contact is driven by the assumption that we will travel there, they will travel here. Obviously, we may receive a radio or some kind of signal of some sort, whatever bandwidth, from another civilization. But is that how we'll actually make contact? It seems to me that the technology of simulating environments, characters, people, is advancing far more quickly than the technology of transportation or the technology, you know, or associated technologies that support that.
So if we could have some sort of holodeck,
right.
we project our characters there,
right.
they project their characters here.
Right.
It would solve our transportation problem. It would alleviate the contamination problem.
Or telecommunications. You know, the reality is that bandwidth is far cheaper if you were to send information than it is to actually propel huge amounts of fuel and passengers and supplies on one-way journeys at unbelievable expense, which of course is what it would be if we could do this today.
But I always have to question, even if we did that, since it would all be virtual, would the public truly believe it? Or would they just say, oh, this is Pixar doing all their computer-generated stuff? Like, you know, they deny the moon landings. So our expectation of the incredible stuff that you do at Pixar might actually undercut such an achievement.
I agree, and frankly, if you're in a mindset where you're going to deny something that is real or there is evidence for that happening, then you're probably going to do that anyway.
All right.
That in itself is a whole different subject.
All right. Well, you've obviously done an amazing amount of work, both in the computer graphics and in thinking about astronomy and aliens. Those are my questions. We have a microphone out there for anybody who has a question. Please, we have a question over here.
And I must say that both of us are staring into lights at the moment, so if we have this kind of dazzled look.
Hi. Do you foresee the ability to create graphics coming down to the consumer level, decent quality CG graphics? And of course, I recognize that there's a tremendous amount of creative force that has to go behind simple rendering. But for someone like myself, I make videos that go on YouTube, educational stuff, things like that, and I often need short little CG segments, but I don't have any way to either pay for them or to create them myself. Do you see anything like that coming down the
Yeah,
pipe?
I would say to date, producing 3D has been more difficult than producing 2D. For example, if you wanted to edit together a home movie, there are various little applications that you can buy that, you can just put together little clips. It's kind of intuitive. You get it, right? 3D, you have to kind of think of an environment. You have to think of objects in the round, how they're lit, how they're textured, and that's always involved a somewhat greater degree of skill and knowledge necessary to do that. I think what's changing, and I referred to this earlier, is the fact that 3D is moving into the realm of physically accurate and physically plausible, where you have to do less cheating and where it's easier to kind of hit a button that says, do it all for me and make it work. So I can well envisage that, for example, in your scenario, that we could see libraries of effects, characters that you could take, that you could repurpose for your own needs, and then say, I just want it to look good. And you hit a button, and it works. And the reason that will happen is because the compute capacity is now becoming available to simulate the whole physical environment in a way that's been known, certainly for the past decade or two, but hasn't really been possible just because of the fact that the data centers necessary to produce this stuff at high fidelity have been very expensive. They still are, but this will change. So I think the short answer is that it will become easier, in my belief.
Right, and I would emphasize your point about the libraries, because the hardest part is to create the character from scratch,
Right.
to create the environment from scratch, to create the table and the chair and all the things that you need.
Right, but there are various tools, for example. There are all sorts of different avenues of research here. There are avenues of research into extracting 3D objects from 2D images. If we have 3D cameras that can take, not only an image, of, let's say, of this room, but the depth information of this room, then it becomes easier to literally extract three-dimensional, forms, models out of that data. So this is a very evolving area of technology, and it changes every year.
Okay, another question? I can't see if there are hands up.
This may seem really silly, but do you think there's ever going to be a time where a Star Trek Enterprise type holodeck will be available for entertainment?
Actually, I do. Yeah, I do. I mean, not in the form that you see in Star Trek, just because it seems physically impossible to have an environment where, what are you touching? What are you holding? But in the development of, the area of immersivity, how you can have an immersive experience. I'm sure many or most of us have seen dome-type presentations in planetarium. That's one example of immersion. There are glasses you can wear that kind of give you that sense of being immersed. And far more speculatively in the future, you look at brain-computer interfaces and all of this. But I think, if you extrapolate trends in technology, I can well see immersive environments developing that are almost so real that you will find it difficult to distinguish them from reality. And that doesn't only involve the visuals, but it does involve the haptic, that's the touch elements of the process, and even smell and other sensory inputs. Taste would be good, especially.
All right,
yeah.
I'm being signaled that we are done with our interview.
Okay.
For the audience, I will note that both Chris and I are on a panel at 11 a.m. today called Imagineering Science, Making Space Cooler Than 3 Degrees Kelvin. If you would like to see some of his visuals and some of my visuals as well, come to Ballroom B at 11 o'clock. And just on my own personal note, if you want to see Hubble 3D, that'll be the film that I worked on. That'll be at 1:30 in the media thing. So let's give Chris a hand. That was a wonderful interview. Thank you.
Thank you. Thanks very much. Thank you, Frank.